All right, everybody. So we're looking at scientific notation today, and we're going to break this down. We're going to do two problems together, and then I'm going to give you a task here. The first one is here. It says, rewrite the following number in scientific notation. Now, I'll do the first one here with you. The second one, the video will pause and give you a chance to work on your own. Now, with scientific notation, the thing you need to remember the most, well, not the most, there's a couple things to remember here, but to start off, what we're going to be doing is we need to remember that each one of every time you do a number in scientific notation, you should wind up with one digit before the decimal place. So I put a space for the one digit, there's the decimal place, and then every other significant digit is what we refer to them as after that decimal place. So for example, when I look at this number, I see that I have 6 is the first digit that is significant. So the 6 is going to go before the decimal place, and then the rest of the significant digits go after. So this is 5, 3, and 2. So now the question is, what do we do after that? And this is where the actual scientific notation comes into play. Okay, so scientific notation will always be 10 to some power. And since we're moving to the left, I like it whenever I have commas because I can just count them. There's 3, 6, 9, 12, and then to get the decimal place between the 6 and the 5, that's 13. So that's 13, and then the only question you have is, should it be positive or negative 13? And the way that I always remember it is that I'm going from 6.532 to a larger number, a much larger number, which means this has got to make it grow. And the only way it grows is with a positive exponent. So this giant number in scientific notation, you can see Mr. Shearer is struggling today, coming back from winter break, is 6.532 times 10 to the 13th power. All right, so try the next one on your own. Notice you'll be a little bit different than what we just did, but see if you guys can pull it off. Hit continue on the video when you're ready to check your work and your answer. Okay, so just like before, you guys know me, I like to have a process, and I follow that process. And I know scientific notation is going to look like this, and I got to fill in those blanks. So one digit before the decimal place, first significant digit is the 2, and then everything else that goes after that goes after the decimal point. So this would be 2.45 times 10 to some power, and I got to figure out how many spaces I moved or how many jumps I moved the decimal place. So there's 1, 2, 3, and it moved. That was a horrible jump, Mr. Shearer. It moved 4 spots, and I should be thinking 2.45 needs to get smaller to get back to the regular number, so that would be a negative 4. So this, in scientific notation, this 0.000245 is 2.45 times 10 to the negative 4. So your task to get ready for the live lesson today, there's 2. I have 2 things for you. 1, task 1, why do we need or use scientific notation? I don't want the examples they give you in the book or on the CK12 content or anything like that. Why do you think it's important that we have scientific notation? What would make it so that these are useful? And 2, what rules do you follow when you convert to or from scientific notation? So have you noticed a pattern that helps you remember what you need to do here for scientific notation. And we're going to share those with the class. Okay, so 2 tasks. Number 1, why do we need or use scientific notation? What's the purpose of this? Because all we're doing is rewriting a number. And task 2, what rules do you follow when you convert to or from scientific notation? All right, we'll see you guys in the live lesson. Have a good one and be ready to share.